they just don't last.
Yes.
They're going to break. And
how does the MACH's engineering maximize performance in extreme conditions?
I should probably start by saying that the whole cavitation or shear environment is a very challenging one. If you consider the high speeds, the high turbulence, the mixing that goes on in those reactors, it's an environment that could very easily lead to failure of the equipment itself. You're trying to be very aggressive on the ore, but it's that same aggression that your actual piece of equipment needs to be able to withstand. And much to the demise of the competition, even though they don't have cavitation units, they've got lesser in terms of the mechanisms. They're based on mixing and shear. It's still very aggressive.
Yeah.
And unfortunately, some of the older technologies don't last very long. And you'll find people that have been in the industry for a long time that have had these bad experiences with the older technologies. And when they hear shear reactors, they think, those are the pieces of machines that they just don't last.
Yes.
They're going to break. And so they tend to be put off it. And whereas it's always good to have the pioneers in the industry, the ones who are the first to break into into an application and to build the first unit. Sometimes it's a bad thing because people will remember all the failures rather than the successes. And when you find a potentially new client, you've got to almost re-educate them.
Yes.
You've got to teach them to unlearn everything they thought they knew about a shear reactor, and then explain to them how the MACH is just so different.
Yeah.
In terms of it not breaking.
You've got to put in that groundwork and
absolutely, it's
help
all about
them believe
education.
it. Yeah.
It's all about educating your potential client before they become a client.
Yes.
But the MACH is a zero maintenance device, so we have units that last over 10 years. And then you've got to ask, and I get asked this question quite a lot by people in the industry: how do you do it? Because it sounds unbelievable. So how did you manage to build a cavitation reactor that doesn't wear out? What did you do? And I think I must start off by saying that we didn't do it by studying the books. So literature gave us some pointers, and we thought, okay, well, if it's that easy and if that's all you need to do, a million other people would probably have done it by now. So we did take those pointers into account, but we did our own testing. We built the first Venturis out of very soft polyurethane material, and then accelerated mine slurry through there, supersonic speeds, and hopefully catch it in time before everything wore out, just to see what is the wear pattern that we get, what is the geometry that it's giving us. And then we fashioned our Venturis for the MACH around those natural wear patterns that the slurry was carving out for itself in the soft urethane. Because if you're going to now give it that shape, it's not going to want to carve out anymore. Yes. Because it has the flow pattern that it's looking for. It has the geometry that it's looking for. So, if you do that, you're sort of winning straight out of the starting blocks because your geometry is right. But you do have to find, the next thing you're going to do is find the right material that can help support and withstand those very high speeds that go up to 30 meters per second of slurry speed. And in doing that, we found that was a whole exercise on its own, because there wasn't a manufacturer of ceramics that had exactly what we were looking for, number one, in terms of the material. And secondly, when we did find somebody that could help us, give us something that we needed in terms of the material composition, they couldn't build the sizes that we need. Because to build a 3,000 cubic hour MACH reactor, there's some pretty big Venturis in there. Yeah. And so we had to sort of hold the hand of these manufacturers, take them under our wing, and then with the promise of lots of business in the future, we got them to build these really big furnaces that could handle the manufacture of these big Venturis. So that alone has been an interesting road to have traveled on.
So it's not only the companies that you're shifting mindsets, but it's the manufacturers that you also have to try and shift their mindsets.
So not only do we have a patent protecting the MACH, all the know-how that goes behind it, there are some components in there that if you're trying to copy a MACH reactor, you're really going to battle to find anybody that can build this for you. Because it is so unique that there isn't something similar out there that you can easily retrofit or reverse engineer it. It'll be quite a mission. But the end result of all of this is, I remember going onto a plant and speaking to a client who had already told me he's totally against these shear reactors. They don't last. And as I was walking to the point of application on his plant, we walked past what looked like a dumping site, and he said to me, yeah, that's the graveyard for the shear reactors. There was a whole lot of them piled up, competitors' units, and he says they don't last longer than a week here.
Wow.
They simply they don't make it. So we dump them there, and then we get new ones.
There's even a grave site.
There's even a grave site, a reactor grave site. So he said your reactor will probably be the same 1 week, and you will have to replace it. So I don't know how, but I managed to twist his arm. I suppose my marketing skills must have been really good.
Give a good sales pitch.
He says, yeah, I gave a good sales pitch. And he said, okay, what do I have to lose? You know, bring it along, we'll install it, and then let's see how we go. And he said, but please bring me at least 2 others that I can keep on the ground. So when this first one breaks, I can replace. And I said, I don't think you need that, but I'll bring it for you all the same. You'll have these spares. And ironically, as luck would have it, that reactor on that plant with that very abrasive chromatite material, that's the one that's lasted 11 years.
Wow.
So it went on to probably the most abrasive environment that a MACH will ever see. And it's lasted the longest.
Wow, so the other 2 formed quite nice decorations around the plant then, hey?
The other 2 are still lying there. They're partially covered in mud now because it's been 10 years. Very dusty, probably cobwebs inside, but I've left them there because he has that, although he knows that he's not going to change anything out, but he always has that peace of mind that he's got spare units. But that has been the culmination of a lot of hard work, design and product development to get the MACH to where it is today.
Wow, that's amazing.